Oh, hey. How's it going? So I guess you're here to learn math, specifically about circle segment length. That's funny because I was just about to talk about that. So let's go. So yeah, I mean, in circles, in addition to having angles, you do have segments. That's correct. And segments that can be formed by chords, secants, and tangents. Let's get to it. First, all right, if you have two chords or secant chord, whatever, mainly just look at chords. If you were to extend the chords, they're secants, but we're focusing on the chords here. If you have two chords that intersect, a very special relationship emerges with the segments that are formed by those intersections. So as you can see here, both A and B used to be part of the same, or they're part of the same chord, but they're new segments that are cut on that chord by another chord. So A and B in this case are related, and segments D and C are also now related. And the relationship that's formed when these two segments intersect would be that A times B equals C times D. So I think of it as part times part equals part times part. And that's what happens. The parts, you just multiply them together for the first chord, and the parts of the second chord, multiply them together again. So let's go. Example time. Whoa, worked out example. I'm leaving that in. All right. So yeah, we have this part. Whoops. So two chords have intersected. So this part is related to this part. Sometimes it's hard to see because they don't use like curly braces or arrows. So you kind of have to just use common sense to figure out which parts they're talking about, especially if the space is tight. And these other two parts are related. So you're just going to multiply the like colored parts now. So I'm going to say that 10 times x equals 14 times 15. Now, 14 times 15 is a pretty big number, and I'm about to divide it by 10, so I'm not going to even multiply that because I'm about to divide it by something, and perhaps, maybe, I can reduce it before I multiply. And I do often say to my students, always simplify before you multiply. So notice how 10 here can be written as 2 times 5. And I'm going to take that 2 and divide it into 14. That becomes 7. I'm going to take this 5 and I'm divide it into 15, and that becomes 3. So the answer to this problem is x equals 21. Let's move on to the next one. So this one looks a little bit more complicated. So why don't you just pause the video and do this on your own? But I am going to say that it looks like the x plus 5 and the x plus 7 are on the same segment, and they're not. So I'm going to just give you a heads up and say, if we're going to do the matching game, this and this, they go together. They're part of the same chord. And then the other two that match are going to be these two. All right. Understand, though, for any of these problems, right, it's possible that you're going to end up with a quadratic and you have to factor. Just keep that in mind. So don't be like, oh, I'm getting weird answers because I have a quadratic. No, it's like totally a possibility. All right, so pause the video. You do this. Welcome back. So if you did 27 times quantity x plus 5 equals 24 times quantity x plus 7, then you're on the right track. So I have 27x plus 5 times 27. So 5 times 27 is 135. 35 equals 24x plus, and then 24 times 7. 24 times 7, I should know this, but 168. All right, and now we solve minus 24x minus 24x minus 135, minus 135. So we end up with 3x equals 33, right? Because plus 30 would get me to 65, so it's 33. And then divide by 3, x is equal to 11. Okay, and that seems to make sense, I'm sure. You can just plug it in and test it. All right, moving on. Now we have another scenario. If you have two secants, right, that are drawn to the circle and they don't intersect on the inside, they intersect on the outside. So when that happens, from the point of intersection, now we're only focusing on that. I mean, if you were to obviously extend these out, you could do that. But we're going to focus on the point of intersection here. So from the point of intersection through the two intersection points on the circle, you get a couple segment relationships. Now, this is interesting. This isn't going to be like A, B, and C, D. You always have to do this. I need you to draw a curly brace, okay? I'm going to try that one again. Whenever you have a scenario like this, you have to do the curly brace and then write the sum of those two numbers. So sad. All right. C plus D. So then what I'm going to do is I'm going to put a ring around the important information again. Outside segment, total. All right, so it's always going to be the outside segment times the whole equals the outside segment times the whole, right? Or in this case, you would write A times quantity A plus B equals C times quantity C plus D. And it's worth noting on there, if you want to write it more nicely, outside segment, the whole segment. Okay, so that includes, like, that's the full chord and then the outer segment. And then likewise, I guess we can do it in red, or we'll do this one in, yeah, let's do it in blue again. Outside and then the whole. Okay, let's put this one to use. You're more than welcome to pause the video and see if you can do this one on your own. I'm going to do it right now. So the first thing I'm going to do is I'm going to put my curly braces in. So 19 and 8 is 27. And 9 and x is 9 plus x. All right. So that means that outside part, yikes, outside part, whole, outside part, whole. So we have 8 times 27 equals 9 times 9 plus x. There's your equation. That's the most important part. The rest, if you mess up, that would stink. But you know what? If I'm grading you, you're not getting, you're going to get most credit for just even setting up that initial relationship. All right, so I'm going to do 8 times 27. 8 times 216 equals, and then 9 times 9 is 81 plus 9x. Subtract 81 from both sides. I'm off the canvas. All right, sorry. And so we subtract 81 from both sides, and we get, let me slide this up a little bit. 216 minus 81. Answer minus 81 is 135. Whoops. Equals 9x. And then so x equals 135 divided by 9. Answer divided by 9, it's 15. All right, there's that one. So why don't you try the next one? So pause the video, see what you get. See you in a second. All right, welcome back. First thing you got to do is curly braces. They don't work when you're in that mode. Curly brace. I'm not going to color code this time either. I'm just going for it. So we know that 8 plus 3x plus 4, you can combine your like terms there. So you get 3x plus 12 is the whole. And then for the bottom one, it's 7 plus 5x plus 2. So this becomes 5x plus 9. So we know that these two match and these two match. Okay, and then we're going to go 8 times the quantity, 3x plus 12 equals 7 times the quantity, 5x plus 9. Distribute, that's 24x plus 96 and 35x plus 63. Okay. Combine like terms. Minus minus 63. Minus 63 minus 24x minus 24x. So you end up with 11 x equals 33 again. X equals 3. I think we got 33 last time. I don't know. So there you go. Hopefully that was clear. And our last one. So this is the other scenario. So we've talked about when they intersect on the inside, right? Two chords. When the secants intersect on the outside, just two secants. Now sometimes one might be a tangent and the other one would be a secant. We learned about two tangents actually. There's nothing crazy about that. If you have two tangents, it's just simply going to be, they're equal to each other. Those lengths are equal. That's one of the first things we learned about tangents. But if you have a tangent segment and a tangent, and then the other one's a secant, it's sort of like, it's just like a hybrid problem, but you'll see. All right, so you can't do anything with the tangent because the outside part is the whole. But with the secant, it's really important, again, that you acknowledge the whole. So this is B plus C in this scenario. So the relationship is simply going to be A squared equals outside part B times the whole, B plus C. So because the outside part is the whole for the tangent, you actually end up multiplying it by itself, okay? So that's why it's A times A, so A squared. And then the secant relationship's still the same. It's just outside part times the whole. So tangent, segment, squared, and then this is outside segment, and this is the, all right, and yes, I didn't change my marker color. What am I to do? I'll just change it now. Okay, so you might want to jot that down. So let's do this one last example. I don't want to make you do two. So why don't you pause the video and see if you can get this one on your own and check back in. All right, so we have to combine the two segments, right? So outside part plus the whole gets the whole thing. And so we have 5x minus 1 plus 8 is going to be 5x plus 7 is the entire thing. So I'm just going to put a ring around the two pieces that are going to be multiplied. And then let's just remember that you have to square this. So let's go 8 times 5x plus 7 equals 16 squared. So I'm looking at this and I'm like, oh, okay, actually 16 squared is going to be divisible by 8. So I can actually just go ahead and do that right now. I'm going to just divide both sides by 8, because why distribute and complicate things and make numbers really big on the left side if I can already reduce the whole entire thing? So 16 squared is 256. Just 256 divided by 8. That I don't know off the top of my head. So 256 divided by 8 is 32. So now we have 5x plus 7 is equal to 32 minus 7 minus 7. 5x equals 25. X equals 5. And there you have it. So hopefully that was helpful to you, and good luck with your understanding of circle segments.